So sometimes the explicit has the advantage. Not always. Sometimes the explicit has the advantage. In an explicit formula, it basically allows you to jump to any term. Allows you to jump to any term. Think about our problem set from today. By the time you guys were done with part C, you came up with this. N times n minus 1 all over 2. That's an explicit formula. It allows you to put in any number and figure out the sequence. Okay? On the flip side of that, you might have done 8 and got 28. You might have done 9 and got 36. So you have 8 is 28, 9 is 36, 10 is 45. Then you can figure out what 11 is going to be. You can figure out what 12 is going to be. You can figure out what 13 is going to be. You start looking at these, and then if I say, well, how many handshakes do you have? You had 25 people in the room. So you have to go through that. You go through that whole list. That's a recursive. Or you can come up with that, plug in 25, and we're done. Okay? So that's the whole point of an explicit formula. It allows you to jump to any term. Okay? It's a very useful tool. So we look at our two sequences now. We have -2, +2, +6, +10. What's happening on every single term there? Malin?
Adding by 3.
We're adding how much?
4.
4. Okay. If you are increasing by the same amount, and what I mean by increasing is you're not multiplying, you're adding or subtracting every single time. Think of that as 4 times n. Well, there's a problem here. What's your third term? The return of that sequence is what? 6. Well, if n represents the term number, so you guys just told me that term 3 is 6. Well, what's 4 times 3? 12. So how much are we off? 6. So what we might need to do is make an adjustment, and therefore we will subtract 6. Now let's see if that works for everyone. 4 times 1 is what? 4. 4 minus 6. So does that match? Okay, 4 times 2. 8 minus 6. 2. If that matches. We already know that 3 matches. 4 times 4 minus 6. So does that fit our sequence? We just came up with an explicit formula. And now I can ask you to go find the 25th term, the 100th term, the 294th term, and just plug them in and go. Okay, so that's the advantage of doing that. Tomorrow I'm actually going to show you a much easier way of doing this, but it's a good way to do it today. Okay, second example, what's going on there? Lucas?
Start out by adding 3 and adding 4 then.
Ooh. Yeah, that's not good. Now I'm increasing not by the same amount. I'm increasing by 3. I'm increasing by 5. Now I'm increasing by 10. What am I going to increase by the next time? Okay. This one's a little more challenging to come up with an explicit formula. I challenge you to figure it out.
I get it.
You got it?
Yeah.
Really?
Isn't it like you just keep adding to it?
Yes, but that would be great for a recursive formula. Well, what about, yeah, that's good, Mackenzie, that's good. But what about an explicit formula? Where I just give you a term number and you're able to plug it in and go. Okay? I'll give you guys maybe 5 minutes. I want you to try that out for 5 minutes. Exponents. what should be the first explanation you might want to try?
X squared.
X squared, okay. Well, let's try that n squared. Look at the first term. First term is -5. We're going to try n squared. Maybe it works, maybe it doesn't. But we're going to try it. What's 1 squared? 1. What might we need to do in order to get to -5? Really? Say again?
You have to subtract 6.
We have to subtract 6. Okay. Should probably check to make sure that's going to work for all of them. What's 2 squared? 4. 4 minus 6. Does that work for that? Okay. Verify that it works for the other two. Maybe it does, maybe it doesn't. What should we do if it doesn't work? I want to try something else. Okay, so does that match our other two terms? Yeah, there we go. So it's n squared minus 6. So sometimes it's going to be really tough. Sometimes it's going to be just a little crazy out there. Just got to keep trying at them. All right, so let's try this again. To describe the pattern, tell me what's happening. 80, 77, 74, 71. Alyssa, what's going on?
They're subtracting them 3.
There we go. We're subtracting 3. Number 2, 4, 8, 16, 32, 64. What's going on there, Sam?
Multiply by 2.
Multiply. By the way, tomorrow we're going to talk about this in more detail. Anytime that you are adding or subtracting by the same amount, we call that arithmetic sequence. Anytime that you're multiplying by the same amount, geometric sequence. So adding or subtracting is an arithmetic. Multiplying or dividing is a geometric sequence. So that's a big idea for tomorrow. You might want to remember that. Okay, 3 and 4. We have to write a recursive formula. Someone remind me, what is a recursive formula? What do you do? Alexis? Yeah, we gotta look at the next term and represent it based on the previous. Alright, so on number 3, what's happening?
You're increasing by 1.
We're increasing by 1, so we're adding 1 to the previous term, right? Adding 1, adding 1, adding 1, adding 1. So a sub n, that's my next term. How do I represent my previous term? N minus 1, so a sub n minus 1. Alright, so we have a sub n equals a sub n minus 1. And what am I doing to my previous term? Because I think you told me what we were doing. What are we doing to each term before it? How do you get the next one? You're adding 1. So the next term is the previous term plus 1. But what's important with a recursive is you have to be told where to start. With a sub 1 equal to what? What does a sub 1 equal, guys? Caitlin? -2. So with recursive, you always have to be told where to start. Alright, so let's try number 4 together. What's happening every time? We're decreasing by 5. So again, my next term, a sub n, I have my previous term, a sub n minus 1, and what am I doing with that term? I'm subtracting 5. But then I also have to say where we're starting. So with a sub 1 equals 6. All right, now these two, these are, I think, the last two we're going to do. All right, here's what I want you guys to do. I want you to work with your partners. And I want you to come up with an explicit formula for each one of these, and then I want you to find the 12th term. Okay. Then we'll come back in probably 5 minutes.